Electronegativity is the power of an atom to attract the electron density in a covalent bond towards itself. Effectively, we use the term electron density because electrons are kind of considered like charge clouds, and therefore it's the way in which negative charge is distributed in a molecule. So say you've got hydrogen fluoride, respectively at very, very small levels. You've got the fluorine is more electronegative than the hydrogen, and therefore you can say that the fluorine is relatively negative and the hydrogen is relatively positive. More will be explained about this in a minute. The Pauling scale is used as a measure of electronegativity. It runs from 0 to 4. An example of something that is at the bottom end of the scale is sodium, which has got a value of 0.9, and something at the higher end of the scale is fluorine with a value of 4. Electronegativity depends on nuclear charge, distance between nucleus and outer shell electrons, and the shielding of the nuclear charge by electrons in the inner shell. So the smaller the atom, the closer to the nucleus the outer level electrons are, so it's got greater electronegativity. Also, the larger the nuclear charge, the greater the electronegativity. So as we go up a group in the periodic table, electronegativity increases because there's less shielding. Go across a period, the electronegativity increases. This is because the nuclear charge increased, there's more electrons in the outer shell, and that's one of the main reasons. So as fluorine is the most reactive because it's got the most number of electrons in the outer shell for that given row, and it's also because it's got increasing electronegativity due to the fact that the outer electrons are closest to the nucleus.